6-2, day 3. I hope you guys count your blessings that I took 3 days to go over this one lesson. So, with that being said, yes, I'm trying to make you feel a little bit guilty. So then later on, when I get in a little hurry, I can go, you guys remember when I took 3 days to cover one lesson? See? All right, let's meet in the middle. So don't get mad at me later. Because I'm doing you guys a massive favor by doing this. Okay, here we go. So as you can see, you've got the square root of, radicans that are letters. And this is where the pre-lesson needs to really hit home today. So here we go. These are easy because they just work out if you follow the rules that were taught earlier. In other words, you say, hey, I'm going to take that radicand, slide it over. This power goes in the numerator. This index, which is an invisible 2 because it's the square root, goes in the denominator. And you go, aha, it's just a to the 5th. Which, by the way, you can test it because what's a to the 5th times a to the 5th? Well, that'd be a to the 10th. Now, let's go ahead and do one more. As you can see, it's a cubic root with a 12, so it's just x to the 12 over 3, which is just x to the 4th. That's what you do. These should be pretty easy if you've been listening a little bit. Now they're going to get a little bit more challenging because as you can see, there's an invisible 2 right here. And if you followed the rule here, you'd go, aha, you'd go a to the 11 over 2. And now you guys have to listen to me. Which is the same thing as a to the 5.5. Please listen. This is not wrong because you're following the rules. This is not wrong because you just turned 11 halves into what it is, 5.5. This is not how Algebra 2 wants you to do these problems. What's the difference? The difference is, on these problems, this is divisible by this. This is divisible by this. So those are easy. When you have a number here and it's not divisible by this, here's what you need to think. I'm going to go to the square root of 27, and I'm going to say, all right, what were the rules? Well, we pulled off the largest, keep that in mind, perfect square root factor of 27, which would be 9. 9 times 3. And that'd be 3 square root of 3. So listen to me very carefully, because I'm going to we'll play on words here. Here's an 11. What is the first number less than 11 that 2 would go into evenly? And that would be 10. See, we pulled off a square root of 9 here. It's the largest perfect square root. There is the largest perfect square root factor of a to the 11th. And if we took 10 away from 11, we'd be left with 1. And now this one is the one that's a 9 that breaks down nice and easy. In other words, what's 10 divided by 2? That's a to the 5th square root of a. I left the 1 out. You can put it there if you want, but you don't need to. So that's the correct answer for Algebra 2. That's what Algebra 2 wants when they give you a problem like this. Okay? Now let's apply that same thought process to this one. Does 14, in other words, does 3 go into 14 evenly? No. What's the first number less than 14 that 3 goes into evenly? That would be 12. If I take 12 x's away from 14, I'm left with 2. Notice this, oops, I forgot to bring that 3 along. That was a big mistake. But notice what's 12 divided by 3? That's x to the 4th. And then this is going nowhere. Just like the square root of 3 went nowhere, this is the part that's going nowhere. So that's the cubic root of x squared. This is the answer for this in this class. Okay? And again, yes, x to the 14 over 3 would be a possible answer. So let's say you're on like an ACT, SAT. Maybe this is option A, this is option B, and later on it says both A and B. you'd have to pick both of them. They don't look anything alike, but they're both the same, okay? So multiple techniques, but this is the one Algebra 2 wants. Now we're going to all of a sudden be dealing with fractions. This is a whole different ballgame. Now listen carefully. This one should be a piece of cake. What's the square root of x squared? That's just x. You see, there's nothing to do there because there's a perfect square root in the denominator. What's our goal? Get the radicals out of the basement. But these darn things are letters now, so we're going to have to think differently. Now, I want you to notice when we were doing these problems over here, you see we were thinking, what's the first number less than 11 that 2 goes into? We said 10. What's the first number less than 14 that 3 goes into? We said 12. Now we're going to change gears. Repeat after me. Bottom bigger. Good job. A little louder, more passion. Bottom bigger. Bottom bigger. Bottom bigger. What am I trying to get through your head? Notice this is in the denominator. Bottom. This is in the denominator. Bottom. These are not. Okay? This we made smaller. These we're going to make bigger. I'll explain in a minute. So, isn't there an invisible 2 right there? See, what we want is a perfect square root because then the square roots it just works out. They just disappear. That's what we're trying to create. Repeat after me. Bottom bigger. Bottom bigger. What's the first number bigger than 3 that 2 goes into? 4. What does that mean I need to do? It means I need to add 1 to the bottom. But if I add 1 to the bottom, I got to add 1 to the top. Now what does the bottom turn into? Well, remember, we can go square root of 2, square root of 3 equals the square root of 6. In other words, we can multiply these things because this is water and this is water. So if I multiply x to the third times x to the first, if you remember your basic algebra rules, you add these exponents. So we would get the square root of x to the fourth, which is just 4 divided by that invisible 2, which is x squared. Then we just bring that along, we get the square root of x. Yes, there's a 1 there, but you don't need it. That would be done. And look what we did. We made the bottom bigger. With that theme in mind, we got an 11. What's the first number bigger than 11 that 3 will go into evenly? 12. So what do we need to do? We need to add 1. But if we add 1 there, then we got to add 1 there. Now on the top, we just get 2 cubic root of x. In the bottom, we multiply these together, but when you have like bases and you're multiplying, you add these exponents. So these 2 would give us the cubic root of x to the 12th power. Why is that a good move? Because now look, 12 is divisible by 3. What's 12 divided by 3? That'd be x to the fourth. And then we put that right there. So as you can see, this has got a little different flavor to it. And there are different ways to do this, but this is the way I've learned that I think students wrap their brains around it the best. If you have a different idea and it works, see me. I'll show it to the class, and maybe some students will like your method better than this. Take a look at that packet lesson now, you guys.